This video covers topic 14.1, which is an introduction to quadratic functions. A quadratic function is a function that can be written in the form y equals ax squared plus bx plus c. While linear functions form a straight line, so remember the word line and linear tell us what kind of line we're going to see. Quadratic functions form a U-shaped graph known as a parabola. The letter U in quadratic can help us remember this. So we're going to use the word bank and label the parts of the parabola listed below. So we have a vertex. A vertex is a point where your graph, your parabola, changes directions. You can have a maximum and a minimum. Your vertex is a maximum when it changes directions at the highest point. So this graph increases up until the vertex and then starts going down. Or you can have a minimum, which is at the lowest part. The word min-u, spelled incorrectly obviously, can help us remember that you have a minimum when your graph looks like a U. A minimum would be like if you were to put your butt in a swing. If this was a swing where you put your butt is the vertex and it's a minimum. A maximum would be if you were to throw a ball to a friend when it reaches that high point and then it starts coming back down. Where it starts coming back down would be your maximum. So we've used these words. Your axis of symmetry is the line shown here. It is a dotted line because it is not something that is actually shown on the graph. You have your axes and your parabola. The axis of symmetry is not shown on the graph, but it represents the point, or the line, where the left side and the right side would match. So if I were able to take this piece of paper and fold it on this dotted line, the left side and the right side of the graph would match, and that is your axis of symmetry. Symmetry meaning equal. And then y and x-intercepts are the same as they were with lines. Your y-intercept is where it crosses the y-axis, and then your x-intercept is where it crosses the x-axis. And remember, your y-axis is the one that has a y, so where it crosses y is your y-intercept, where it crosses x is your x-intercept. Notice that we have two x-intercepts because it crosses two times. Okay, so problem 1 is the simplest quadratic parent function. The simplest quadratic function, which is the quadratic parent function. It has the equation y equals x squared. Your vertex is a minimum. And when it says vertex, they are asking for the point. We are just reminding you that this is a minimum because it looks like a U. Your vertex is the point where this swing, where you would put your butt in a swing, the point where it changes direction. So it goes down, and then it starts going up. So that vertex is at 0, 0. Your x-intercept is where it crosses the x-axis. The only point that it touches or crosses the x-axis is at your vertex. Your y-intercept is where it crosses the y-axis, which also happens to be 0, 0. The only time this will happen is the quadratic parent function. To fill in the table, everything bounces back up. So when when x is negative 1, y is 1, negative 2, 4, and negative 3, 9. So notice, my axis of symmetry is where these points will meet. So negative 1, 1, and 1, 1 are the same on the right and the left, and they will meet in the middle. Your axis of symmetry, I know it's down here at the bottom, is x equals the x point from your vertex. So because my vertex is 0, 0, my axis of symmetry is the equation x equals 0. Your domain will always be all reals because you can plug in any x value and get out a y value. Your range will always be related to the y of your vertex. In this case, because I have a minimum meaning lowest point, my y's are all getting bigger. So my minimum 0, or my minimum y value is 0, and then my y's are getting bigger. So my y's are getting greater than or equal to 0. So your vertex is important because the x goes to the axis of symmetry and the y goes to the range. Problem 2, we have the quadratic parent, or the quadratic function, not the parent function anymore. X squared plus 2x minus 8, graphs below answer the following. So first they want the vertex. The vertex is your lowest or highest point. In this case, my lowest point is down here. So this would be the point -1, -9. Remember your points go x, comma, y. So -1, -9. This is a minimum. It is a minimum because that is the lowest point. Also, the word min-u helps us to remember that. Your axis of symmetry is x equals the x from your vertex. It is always an equation. If you do not write it as an equation, it is considered incorrect because the axis of symmetry is the dotted line that is right here. X equals -1. If you just put -1, we don't know if that's an x, if it's a y, if it's a point, if it's an intercept, if it's a number that's random. So you have to put x equals the x point of your vertex. Y-intercept is where it crosses the y-axis, so my y-axis is the one that goes up and down. It crosses at -8. So remember, whatever intercept letter you have, like we have a y, so my number goes in y, and 0 goes in for x. My x-intercepts is where they cross the x-axis. They cross at 2 and -4. Again, we have x, so 2 and -4 go in my x spots, and then 0, 0 for the other parts. Domain is always all reals. My range is related to the vertex, the y of my vertex. My vertex, when y is -9, is way down here, and my y's are getting greater than. They are going up, so it's greater than or equal to. Part G says, for what values of x does f of x equal -5? If they are asking you for x, that means they're not giving you x, which means they are giving you y. So they are giving you y is -5 and asking for the x values. So I'm going to go to -5 and draw a line going across. Y equals -5 is a line going all the way across. It is a horizontal line. Now that line crosses my parabola, my U-shaped graph, at these two places. It crosses at -3 and at 1. So my values are going to be -3 and 1. You can put the and sign, you can put the or sign, you can put the comma. You cannot put like 1 minus 3 because that's -2, and that means nothing to us because that's not correct. Problem H, ask for the value of A, B, and C. Remember, these are in standard form. We've rewritten it for you here. A goes with x squared, B goes with x, and C is the number by itself with no letter. So all you do is replace A with 1 because that's the invisible number in front. B, there's a 2 in front of x, and C is a -8. So A, B, C goes in order. As long as your x squared, x, and number are in the standard form order, decreasing by exponent, it literally is as easy as A, B, C, 1, 2, -8. We are not Michael Jackson, but it is that simple. Problem 3 says that we are looking at part of the function for g of x, which is -5x squared plus 40x plus 45, and it's shown below. My maximum point, they're telling me this is a max because it is a hill. The maximum point, or my vertex, is at the point 4, 125. Now that 125 is just an estimate. You could put 127. Anything between 120 and 130 would be acceptable. My line of symmetry, or axis of symmetry, is x equals the x from my vertex. So my axis of symmetry is this line, x equals 4, and that goes through the vertex, and that is where if I folded it on this line, the left side would equal the right side. My y-intercept, it crosses the y-axis at about 45. My x-intercepts, it crosses at 9. There is another y or x-intercept. Now, if we can't see it, we can use this axis of symmetry to our advantage. From the axis of symmetry to my x-intercept is 5 points. 1, 2, 3, 4, 5. Remember, the axis of symmetry is where you could fold and the right side would match the left. So if we go 5 on the left side, that will be the same place as my vertex over here. So from my axis of symmetry, I count 1, 2, 3, 4, 5. So that would be the point -1, 0, because it's 1 past 0. So we can use that axis of symmetry to our advantage. Domain is all reals. Range uses the number from your max point, the y from your max. Now, if 125 is my max, it means my y's are getting lower than 125. So my y's are less than or lower than 125. F asks me for the best estimate of the largest value of x for which this function equals 80. So they are giving me a y value at 80. So I'm going to draw a line through 80, and it crosses here and here. Now this time they don't want both values, they want the largest value. So my values are 1 and 7, but 7 is the largest, so I'm only going to put 7. Okay. And then remember, as long as you have x squared, x, and number, a, b, c, literally follow -5, 40, and 45. They follow the exact same order as long as you have them in the correct order. If they are not in the correct order, then you need to put them in the correct order before you say what a, b, and c are. Problem 4 tells me the function g of x equals 2x squared minus 14x minus 36 is graphed. Answer the following. So what are the values of a, b, and c? We have x squared, x, and number in order, so we just rewrite the numbers. My y-intercept is where it crosses the y-axis. So it crosses at about -36. My x-intercepts are where they cross the x-axis, and we need to be careful here. Every bold tick represents 1, 1, 2, 3, 4, 5, but they don't show all of them. So from 5, 6, 7, 8, 9, and then -1, -2. So 9 and -2 are my x-intercepts. Domain is always all reals. Range is from your vertex, but we don't have the vertex yet, so we need to go figure out the y point of my vertex. This is about -61. It could be -60, could be -61, so you can estimate there. And then because I have a minimum, my y's are going up, so my y's are getting greater than -61. Part E, the best estimate for the largest value of x for where the function equals -20. So I go to -20 and draw my horizontal line. It crosses here and here. They ask for the largest value, so my values are -1 and 8. Largest value of that would be 8. There are summary questions on the bottom that you do not need the video to go through, so make sure you answer those so you get full credit.